Hello everyone. I wanted to take a moment and to go through the questions that we see on our review about average atomic mass. And so if you want to follow along with me in your review, that'd be great. We're looking at, let's see, question 24, proficiency target number 5. This is our more math-heavy concept, so that's why I wanted to make a practice video in order to help you guys prepare and study for the exam. So our first question here says lead has 4 isotopes. 1.40% of all lead atoms are lead-204. And 24.10% of all lead atoms are lead-206, 22% of all lead atoms are lead-207, and 52.4% of all lead atoms are lead-208. What is the average atomic mass? In order to figure out the average atomic mass, I need to consider all the different isotopes. And there's 4 isotopes. So if I am calculating average atomic mass, I need to take the mass of an isotope, one of the isotopes, like the first one is 204, the first isotope is 204, and then I have to multiply it by the decimal form of the percent abundance, or the fraction form, because it's in a percent right now, and we got that by multiplying by 100, so we need to divide by 100 to take it out of that form. And I will do this 3 more times because there are 4 isotopes in total. Okay. So we also had a second isotope, which was 206. And then we had another isotope, which was lead-207. And then our last one was lead-208. So this is the equation that we're going to use. Now let's make a list of knowns and unknowns from that problem. So it says lead has 4 isotopes. 1.40% of all lead atoms are lead-204. So this percentage of 204 is 1.40%, but that's in its decimal form. So that's in its percentage form. In order to get it into our decimal form, because right now it's at 1.40%, I need to divide by 100 or move the decimal to the left 2 times. So instead of plugging in right here 1.40%, I'm going to put 0.0140. And that's what will go here. This particular problem doesn't give us the exact atomic masses of our isotopes, so our best approximation for the mass is going to be the mass number provided. The mass of 204 is approximately 204 AMU. Now, if a problem gives you a table and it tells you the exact number for the mass, then use that instead. If it doesn't, then we can make a pretty good approximation using the mass numbers instead of the atomic mass of the individual isotopes. So I have my decimal. Now let's keep reading. We have 24.10% of all the lead atoms are lead-206. So if I'm going to move my decimal place over 2 times, for 24.10, that'll change to 0.2410. Okay. And then again, I don't have the exact atomic mass for 206, so I'll use my mass number as a good approximation of what that mass should be. And then the problem goes on to say that 22.10% of all lead atoms are lead 207. So 207 has an abundance of 22.10%, and I'll move that decimal to the left 2 times. So it'll be 0.2210. And the mass of 207, we're going to say is 207 AMU. And then our last one that we have is the decimal, the percentage of 208. And the problem says that the percentage is 52.40%. So to take it out of that percentage, I divide by 100 or move the decimal to the left 2 times. And then our mass of 208, is going to be approximately 208 AMU. Okay. Let's see if I can fit this all in. Okay. So, now that I have my big, huge list of knowns, I can recognize that what I'm solving for is average atomic mass. The problem says, what is the average atomic mass for lead? The equation that I've already put together is already solved and rearranged for average atomic mass, so I don't need to rearrange this equation. All that's left to do is to plug in these numbers. So I'm just going to do that. I've made my list of knowns and unknowns, so I really don't have to rewrite and declare exactly what these numbers are a second time. Average atomic mass is going to be the mass of 204, which is 204, multiplied by 0.0140. I will add that to 206 multiplied by 0.2410, and that will all be added to 207 multiplied by 0.2210, and then our last isotope is 208 multiplied by 0.5240. Okay, so Gen Chem, give me 2 or 3 digits after the decimal, so like 207.241 AMU. Honors, consider your sig figs. So like originally this was 3 sig figs, 3 sig figs, 4 sig figs, 3, 4, 3, 4, 3. So we're going to go with 3 sig figs, so it'll round at 207. So my final answer for average atomic mass would be 207. What's my units though? The mass is in AMUs, and then this is unitless, so it's AMU plus AMU plus AMU plus AMU. Well, if you're just adding the same unit together, then you end with that unit. Like if you did meters plus meters plus meters plus meters, etc., your final answer would just be in meters. It's the same thing for AMU. So our final answer, average atomic mass for our isotope here, is 207 atomic mass units. Okay. On the next video, we will cover a situation where we know everything except for an unknown within the equation, like one of the isotope masses or one of the percentages. So if you're an honor student, I highly suggest that you check out the second video.